what's crazy. The fact that I have two phones filming me. That's pretty nuts. And one camera. Pretty nuts. But it's... What?
There's a whole bunch of tensioning going on. And down here, and do a bunch more inspection notes. So camera inspection, X-ray. Yeah. So you have long tongs to reach into the machine to get it and put it out. Yeah, got it. How often does that happen?
So that could happen like twice a day.
Twice a day?
Yeah, that could happen.
Oh my god, that sounds exciting.
Yeah. I don't want to happen.
Right, no, I understand. I wouldn't want it to happen on my machine either. Yeah. So the next step, now that the BMS is attached, is bending it into the right orientation. And that's what this machine does. Is at least what's happening here. Mr. Young, this machine here, what does that do? I can't see if it doesn't look like it's doing anything.
这个机器呢，主要是成型，就是弯子这个。
Right, but that's what this is doing. What about that one?
这个呢，因为我们其他有一个气缸配件呢，你现在还在更换中，我们在维修中。哦，对，那个还没起作用。对，起完作用，我们还贴上这个查受绝缘的，啊。哦，这个贴绝缘的。对。这个是贴到绝缘。Yeah. So this is for isolation. This part, but at the moment, because they have the part, they have to be installed. So at the moment they can't.
Oh, it's just broken.
Yeah.
Broken. Yeah. Okay.
So that part, the function is to isolate.
So they've got women doing it in my hand right now. Yeah. Okay, I got it. Oh, I see. Okay, so here he's adding more complex bends to the cable where it plugs into the iPhone. There's some extra crimps. So these here are totally flat, and he's adding all the necessary bends on this so that it fits into the iPhone in the right orientation. And then they're just putting tape to insulate, is that right?
Yes.
Yeah.
This is another half menu, like auto machine.
Yeah.
So they put it here, there, and then they put
Oh,
it
and that's just putting this
Yeah.
yellow caps on.
Yeah,
I
they-
see. So there's some tape and stickers being put on
the
the
other
machine
side.
over here.
Yeah,
it's
Okay,
insane.
so we got stickers going on here. And then we got another turntable. Let's figure out what this turntable does. So the batteries are coming in over here, getting loaded by this one. And then tape being put around, folded down. They put on the conveyor belt back over there. And she is checking that everyone is correct and fixing them if they're not, one by one. This one is not working today. Is that right?
这个今天不开吗？今天不开。Yeah.
But this is normally the machine that checks to see if there's any like liquid leaking from the battery. Okay. They told me this earlier off camera. Okay, so let's go ahead and we'll go to the next step. So some of the steps are being worked around with people right now. Batteries are coming off the line here.
Yep.
Then you guys told me earlier. My understanding is that the batteries now sit for 72 hours. Is that right?
对，老化。
Why are they sitting?
这个主要是呢，放那边呢，主要是放一个搁置，搁置完之后呢，它会出现一种，就看有没有一些漏液啊，或者电芯补包这种情况。
Oh, to see if any liquid comes out.
Comes out leaking.
Okay, so to see if it's been punctured, like there's a hole in it.
That's right. And then also, it's checking the internal resistance,
Right.
whether there's bad quality ones that have a high resistance, so they have to throw it out.
Okay, so they sit for 72 hours in a storeroom,
Yep.
and then they come out here for testing, right?
对。
Let's go look at that next. I just want to add as an aside, we came through earlier with some of the higher managers, and I got kind of an overview of the process. So I'm not explaining this to Mr. Young. He totally knows what's going on. I'm just making sure that my memory is correct, so I'm not saying the wrong stuff. Okay, so we're testing voltage and impedance, just basic battery testing. So these machines here, these testing machines, are these machines that Hinson made or from someone else? Third party. Yeah. And what are they testing? Because he's testing voltage. What are these guys testing?
这边也是测一种解码的解码的，合格之后呢，这个产品就出去包装。如果不合格，我们是要区分出来。
Okay, so we're making sure that the batteries are compatible with an iPhone, and that they can be read by the iPhone. Is that right? So the iPhone can talk to the battery management system to see how much charge is there, what is the current flowing, serial numbers, manufacturer information, things like that. There are a lot of people testing here, plugging in one battery at a time. Here we are at the last stage of the process. We've got batteries ready to go to the customer. We got to put them in boxes. So over here, we've got trays, plastic trays that go inside the box. She's adding the battery strips that you need to add them to your phone, putting the batteries in those trays, putting them on the line. And there's a cover piece of plastic that goes on top before it goes into the box. This right here is quite cool. So this is a camera that's taking a picture of the QR code so that they know what battery went into what box. There's a QR code on the outside of the battery, and somewhere down the line here, they're then scanning that and matching the two together. We've got boxes ready to go. Here, there's the QR code. Each one of these barcodes is unique, so they know they can differentiate every single battery from each other. This machine is literally opening the box. Oh, here's the barcode scanner right here, and then stuffing the battery in. How cool is that? But this beats everything. This is an automatic box closer. It's flipping over the flap on the bottom and tucking it in. Next is my other favorite machine. This is the sticker machine. This is putting those little clear dots of adhesive, of sticker, over the bottom flap to keep it closed. They're on the roll here. They're really hard to see, but there are little circles here. They're being flipped down on here, and then this brush is sweeping down over them to stick the bottom part right here on. Then finally, this is printing the manufacturing date. So there's a little black print in here that just says when it was manufactured, what batch, that kind of thing. And then finally, we go into the shrink wrap machine. And this is just adding the shrink wrap on the outside of the box. I don't know quite why they do this, because it's not over the top and bottom flap. But my guess is that it keeps the artwork on the box looking nicer. Finally, we take the little boxes, and we put them in medium boxes. And then we put the medium boxes in big boxes. And of course, they're scanning barcodes all along the way so that they know what went where. And finally, we have a finished product ready to put on a shelf. Lastly, I just wanted to quickly show you their testing lab, their quality control facility, where they test new batteries, test quality of batches. And one of the things they do in here is do temperature and humidity testing, just to make sure that the batteries don't do anything scary when they heat them up or there's really high humidity. So this is a humidity and temperature testing chamber. Over here, they're doing real-world device testing. So they're taking those iPhone batteries and they're putting them in an actual iPhone and seeing how long it takes to discharge. So they can accurately say it lasts for 10 hours, it lasts for 12 hours, whatever. The really cool part is that this is a webcam pointed at the battery display here. So they're actually videoing this battery as it decreases, so they know the exact moment that it hits zero. And so they've got an iPhone here, I've got a couple more iPhones here. They had an iPad out earlier when we came through the first time. Super cool. So here, they have a spectrometer for ROS testing, R-O-H-S, which is the environmental standards around what elements can be in whatever product you're producing. The most important one is lead, so lead-free solder, things like that. They're testing various parts that go into the batteries here to make sure they conform to those standards. In here, they have all the really crazy tests. So here, this is a salt mist test. They're spraying salt water all over the battery to make sure that it doesn't short out and blow up. Here, they have a furnace, a blast furnace. So they are a furnace that controls blasts. So they are cooking the batteries up to 130 degrees Celsius to see if they puff up but don't explode. You know, the biggest concern that consumers have with lipos is, you know, they catch fire, right? The famous, you know, Samsung Note Note 7, catching fire on airplanes and causing all sorts of problems. This is them testing to make sure that that doesn't happen with their batteries and that they're safe to within the limits that are reasonably going to happen. It's good to know they're paying attention to it so that we don't have to. That about does it for this time. I'm Scotty from Strange Parts. This is Pinson. I want to thank them for giving me access to their factory. If you want to find out more, click the link down in the description. But for now, make sure you hit that subscribe button so you don't miss more factory tours. I'll see you again soon.
'Successful entrepreneurs and giants do that. Why I can't produce my own stuff? About my own life, my own face, my own history, my own story, and just post it out there on the YouTube, and the internet, and everywhere else, right?
It's the fastest, most extreme, and most exclusive production super sports car in the world. The French-made vehicle shoots along the road at a top speed of 420 kilometers an hour. This hypercar scratches at the boundaries of physics, a motorized superlative.
It is this ambivalence between beauty and beast.
To awaken interest in this ultra-powerful
Did you
engineering
hear
work of
that?
art, the developers have made the
Ambivalence.
best even better.
You start working where others have stopped.
The mission, a hyper sports car with 1,500 horsepower and a top speed of 420 kilometers an hour.
The whole world said you'll never manage to cram so much power in a car.
The whole world was wrong, but the enormous power concealed in this rocket poses new challenges.
You have to be sure that you've still got enough weight on front that it won't take off.
To ensure a healthy body mass index, the Alsace engineers have fitted the all-wheel drive vehicle with lots of carbon, titanium, and magnesium.
That shows lots of things you would normally only find in Formula One cars.
And the elegant top athlete with the 16-cylinder engine is anything but normal. The design engineers all agree about that.
Can you compare the Chiron with another vehicle? No.
God created heaven and earth, and the French created the Bugatti Chiron. The spearhead of vehicle construction is located in Mosheim, France. The Bugatti Hyper Sports Car Manufactory. These record-holding dream cars have been built on the site of the former family estate for the past 110 years. Built in 2004 in the form of a company logo, the Alsatians lovingly refer to the new production building as the Dream Factory. Inside, 20 employees assemble up to 16 vehicles at the same time at 12 stations. With these production figures, Bugatti is part of the haute couture among vehicle manufacturers. The Bugatti Chiron is the flagship of the current collection.
It's a lot of manual work. It's like in a Formula One racing stable. Everything's handmade at various stations. Some 300 people work at Bugatti. Engineers, sales representatives, and purchasers. People who share a passion to develop, build, and sell super sports cars.
It takes 2 months until the French have assembled around 2,600 individual parts to form a new motorsport work of art.
Everything's handmade at various stations. Some 300 people work at Bugatti. Engineers, sales representatives, and purchasers. People who share a passion to develop, build, and sell super sports cars.
It takes 2 months until the French have assembled around 2,600 individual parts to form a new motorsport work of art. The Chiron's hood conceals pure performance. The world's most powerful production engine has 16 cylinders and a displacement of 8 liters. This enables the Bugatti to reach its record-breaking speed of 420 kilometers an hour. 4 offset operating turbochargers accelerate the 1,500 horsepower projectile from 0 to 100 kilometers an hour in just 2.4 seconds. Instead of a classic production line, there are 4 special stations in Molsheim. They each contain 2 independent lifting platforms. Because the sports coupe is made up of 2 parts, which the employees marry with one another during production. 3 mechanics always assemble what is called the Chiron's rolling chassis strictly by hand, the drivable naked vehicle skeleton. An expensive delivery is waiting at the Bugatti cargo ramp. This body component heralds the construction of a new all-wheel drive behemoth. The monocoque is a hollow driver cockpit and is made entirely of carbon fiber reinforced plastic, or CFRP. 4 steel journals now rise up out of the gleaming shop floor. 2 workers install an assembly platform on them. The production crew then heaves the 150-kilogram carbon framework onto the platform. Each material that the Bugatti design engineers install fulfills a specific purpose.
The materials we use at Bugatti are the finest, but also the lightest available. We use lots of magnesium, titanium, carbon, and aluminum. Lots of things that you would normally only find in Formula One cars. There are no miracles in technology. Our Bugatti Chiron is capable of topping 400 kilometers per hour and can accelerate from 0 to 100 in less than 3 seconds. We're talking about numbers and performance that are somehow unreal. But this simply represents a lot of work at the development and also at the production level to ensure this performance is always achieved.
The technicians install the wiring harness inside the carbon cockpit. The harness consists of 2.5 kilometers of cables and is the nerve system of the Chiron. It connects the vehicle's 20 control units. The mechanics fasten the electrical wires to the monocoque with titanium screws. Like all of the other elements in this racing machine, the wiring harness is also designed as compact and light as possible. The rear frame of the exclusive coupe is assembled on the second platform. But first, the workers move the assembly frame to the heart of the Bugatti, the 640 kilogram 16-cylinder engine. Due to the size and the enormous weight of this unit, the assembly platform comes to the engine in Molsheim. The mechanics use a crane to put the German-built high-performance power plant down on the assembly platform. The engines are manufactured at the Volkswagen engine plant in Salzgitter. Covering 2.8 million square meters, this site boasts its own Bugatti department. Whoever works here belongs to the absolute elite among engine mechanics, as the 16-cylinder is considered to be the holy grail of engines. 2 technicians need 1 week to build one of the 1,500 horsepower quad-turbo engines.
We build a car that does over 400 kilometers an hour and drives elegantly to the opera in the evening. To do this, you need not only a car that can achieve this, but also an engine that's capable of driving in the summer and winter, in cities, traffic jams, as well as on racetracks. That's something of a challenge. Formula One teams are good at building racing engines with lots of power, and Volkswagen is adept at building good engines for the road, for golf. This combination of 2 worlds is Bugatti's specialty.
Christened production nests by the technicians, the 4 workplaces
Sorry,
in the
George.
engine department are also special. The station is structured so that a complete unit can be built here. The experts manufacture a total of 3 of these powerful heavyweights per week. To make the engine as compact as possible, 8 cylinders are distributed over each of the 2 V-shaped banks, thus creating an artificial W engine with 16 cylinders. The W16 achieves its maximum acceleration with 4 high-performance turbochargers. Via a turbine, the quartet compresses the air intaken at the front of the vehicle and presses it into the combustion chamber in stages. Thanks to what Bugatti calls sequential turbocharging, Turbo 3 and 4 cut in at 2,800 RPM. This prevents turbo lag and therefore ensures constant power. At Production Nest 2, a new crankcase is ready to be assembled. A mechanic has just installed the pistons in the 16 cylinders and connected them to the crankshaft. Before the engine builders continue their work, they use an electronic torque wrench to simulate engine operation. For instance, this allows the workers to check that the piston stroke does not lead to friction on the cylinder wall. Otherwise, serious engine damage called piston seizure could occur later while driving. The Chiron's engine is made up of around 3,700 individual parts. The technicians pre-assemble individual components at workplaces next to the assembly stand. This worker is assembling various engine elements. Here, he is fitting a fuel pump. Later on, it will deliver the required quantity of fuel to the engine. The worker then installs the alternator. Its task is to generate electricity for the starter battery and other electrical components. At the same time, his colleague prepares the oil pan for assembly. It has to be absolutely leak tight, because later on the pan contains the engine oil needed to lubricate the 16-cylinder engine. This is why the technician now takes it to an automatic station. 2 different processes take place here. First, a special oxygen plasma cleans the surface of the pan. Although the engineers pay strict attention to cleanliness, there is still a fine layer of dirt on the components. The station then applies a black sealant onto the edge of the magnesium pan. Once the sealant has been completely distributed, the technician has 20 minutes to assemble the component. To do this, he positions the oil pan over the crankshaft onto the lower side of the engine block and seals it. Only specially trained technicians are permitted to build the Chiron engine. Whoever has successfully completed the additional 2-year training can justifiably feel proud.
I'm one of a total of 8 technicians worldwide who are permitted to build this engine in series. Of course, that makes you very proud. It's like you made your hobby your vocation.
You can already get a sense of the enormous dimensions of the combustion engine at Station 3. The quad-turbo engine draws its power from the ignition of a fuel-air mixture. These camshafts ensure the correct mixing ratio. Driven by the engine's chain, the cams rotate around their metal shaft and thereby press alternately on the valves of the individual cylinder heads. This enables them to open and close in a specific stroke. The mechanics bolt 2 of these 1-kilogram engine components per cylinder bank. W16 engine in the Chiron has a total of 4 camshafts. So that the mixture can ignite, the engineers now insert 16 spark plugs into the cylinders. They supply the final torque for starting the engine.
Let me try this thing. I like California. Yikes.
And the engine is at the heart of it. An 8-liter engine with 16 cylinders and up to 1,600 horsepower.
However, the objective of building the world's fastest production sports car in the form of the new Chiron was viewed very critically by the industry.
The whole world said you'll never manage to cram so much power in a car. But a displacement of 8 liters over 1,000 horsepower is a conventional task. You add turbochargers to it, at some point you achieve that power, and then you're faced with a big problem that you can't find a test bench anywhere in the world that can cope with this power.
But the engineers solved precisely this problem. On an internally developed test stand, they put the 8-liter engine through its paces until the manifold glows. Once completed, the engineers test the power output and, above all, the durability of each power plant. Behind the roughly 30-centimeter thick safety walls of the test booth, the team has strapped the combustion engine down and coupled it to a dynamometer. It's able to demand the engine's full output of 1,500 horsepower at 6,700 revolutions per minute. The stress applied on the test bench is significantly higher than during vehicle operation.
An engine is tortured for up to 1,000 hours on the test bench.
Das sind
That's hundreds of thousands of kilometers on the road. If an engine has survived that, it can survive anything.
A gigantic blower cools the engine during the test. Special sensors measure a total of 500 different values, which the testers check on the monitor. The tests were also an important part of developing the 16-cylinder engine, because the results were incorporated into its 3D model and helped the design engineers to detect possible critical areas. It took 3 years to develop the Chiron's power plant. Often, optimization requirements also arise due to legal specifications. Corresponding measures that the engineers plan on their screens then have to be verified on the real component. During a special auditory test, an acoustic engineer checks whether the exhaust system simulation matches reality. To do this, the sound expert applies a pure tone to the exhaust tailpipes using a loudspeaker. The sound causes the air particles inside the system to vibrate. The engineer records the resonance using a microphone. This allows the sound and the volume to be viewed on the monitor. By 2026, passenger car driving noises have to be reduced to 68 decibels. That's roughly the same as a television at low volume. At the same time, however, the engine sound must not suffer. The acoustic factors are particularly crucial to the experience of driving the Chiron.
What the driver's hearing is an entirely unconscious process. Nevertheless, he needs specific information. He wants to know when the road changes. He wants to know whether the engine RPM is too low or too high. He wants to know what the absolute vehicle speed is via the wind noises. If any of this information is missing, the vehicle is perceived as unharmonious. The rolling noise is relevant. How the windows are constructed, how well the chassis is insulated from the cockpit. All of this characterizes the overall noise perceived by the driver. This all has to be composed to form a consistent picture to achieve a positive experience in the vehicle's interior.
And who better to test this experience in new models than a genuine motor racing expert? The former Le Mans winner, Andy Wallace, is Bugatti's test driver. He has already driven around 100,000 kilometers in the luxury sports car from Molsheim. An absolute dream job. The Briton also provides the developers with direct feedback about the Chiron's performance and handling from the driver's cockpit.
If you like cars and you can maybe dream about supercars, this one is the top, the very top of the pile. For me to be able to drive this car every day, if you told me that when I was 7 years old, I never would have believed you. So for me, it's fantastic.
However, Wallace will be thinking about the following drive for a long time to come. With this Chiron, the Briton will set a new speed record of 304.773 miles an hour, or 490.484 kilometers an hour. The Chiron Super Sport 300 Plus pre-production model offers an additional 100 horsepower, totaling 1,600 horsepower. On the test track in Iradesin, Germany, its tires will be rotating no fewer than 4,100 times per minute. This would be the first time in history that a production vehicle breaks the 300-mile-an-hour barrier. And off he goes. Andy Wallace floors the accelerator and is already doing 100 kilometers an hour 2 seconds later. Covering around 11 square kilometers, the test site lies at the center of a pine forest. Curves and straights follow in quick succession. This makes it difficult to keep the vehicle on track.
You're constantly turning to go straight. And this is at the same time that you're travelling 136 metres per second. Everything's coming at you really, really quick. So the senses coming into you are crazy, and you have to try and keep all that under control. And it's not something you do every day, so it's not something you can practice. You just end up doing it. and it's pretty impressive.
3.5 kilometers ahead of the record. The Chiron is still picking up speed. The down thrust, also called downforce, on its rear end increases. This causes the front end to lift. The Bugatti uses a complicated aerodynamics concept to counteract the principle that helps airplanes to take off. After 70 seconds at full throttle, Wallace breaks the record.
Wow, guys, what a fantastic car. Dankeschön, grazie, merci. I can't thank you enough.
In the atelier in Molsheim, France, a worker transports an important component to a newly arrived engine block. Two mechanics now couple this 7-speed direct shift transmission to the power plant. The automatic shift unit ensures constant power output when shifting gears. Because one clutch closes at the same time as the other is opening, the automatic transmission ensures consistent tractive force. The workers then take the new drive unit to an assembly station. Covering 1,000 square meters, the